All right, so let's finish this 5.3 through 5.5 homework assignment, the multiple choice. Continuing on with the same stuff we covered in the first part right here, we're going to be talking about increasing and decreasing intervals, the first derivative test, and the candidates test. So let f be a function defined given here. On the interval from negative pi halves to pi halves, which of the following open intervals is f increasing? So let's take the derivative. So we'll do f prime of x. So we'll have to use the product rule. So we'll do the first times by the derivative of the second, which will be e to the negative x, and then we'll have to multiply by a negative. Okay, so the first times the derivative of the second plus the derivative of the first, which will be cosine of x, times by the second. Now, a lot of times if you have a product rule and it involves using e to the x, you're going to see that that is always something that can be factored out. And so this will be e to the negative x, and I do recommend you factoring it out if you're going to set it equal to 0. And then I'm just going to rearrange this cosine of x minus sine of x, just because it looks a little bit better that way. And we're going to set that equal to 0. Now, e to the negative x never equals 0. Keep that in mind. E to the x, e to the negative x, e to the x squared, e to the negative x squared never equals 0. And so it just depends on when this is equal to 0. So when will cosine of x minus sine of x equal 0? That's going to be when cosine of x equals sine of x. So when do cosine of x and sine of x equal each other? So there's a couple different ways you can think about it. If you think about the graphs of sine of x and cosine of x, you can think about sine of x, which goes like this, right? Which will go like that right there. Then you can think about cosine of x, which starts at the top. Okay, it's going to cross, then it's going to go right here, and then it's going to go right here. So when between negative pi and pi halves and pi halves, so where is pi halves here, though? So this is pi... That's pi halves right there. And then you can, so if this is pi halves, this is very difficult to see. So that's pi halves. So you can see where they intersect right there. That's where they're going to be equal to 0. And it's also going to be negative pi halves. So at negative pi halves, they should also cross each other. But I can tell you right now, just from knowledge and experience, that they'll be equal to each other at pi fourths. So when x is equal to pi fourths, and probably negative pi fourth as well. Right? So let's, I don't like looking at the graphs. So let's just think about the triangles. I like to think about the triangles a little bit better. So if you have so pi fourths is a 45 degree triangle. So if you have a 45, so pi fourths, then this is equal to 1 and square root of 2. So, and at negative pi fourths, no, they will not be equal to each other at negative pi fourths. So if you show negative pi fourths, so negative pi fourths, they won't be equal to each other because y will be negative right here. And so sine of this angle is 1 over root 2, and so is cosine. Cosine is also 1 over root 2. But sine of negative pi fourths is negative 1 over root 2, and cosine is positive 1 over root 2. So no, I think the only time that they will be equivalent to each other is at x equals pi fourth. So when x equals pi over 4. So if I look over here, I can see... Okay, I see the intervals. Oh, wait, no, I'm not looking for the answer just yet. I need to test, we need to use I like to use the table anyways. So we have from negative pi over 2 to pi over 2. That's what we're going to be contained within. And then we know that at pi over 4 is where this is going to be equal to 0. So pi over 4 being over here. And then we're just trying to see if the derivative is positive or negative. So we're thinking about f prime of x. So f prime of x. Let's think something easy. So let's use 0. I think 0 would be easy to plug in. So since this never equals 0, and because we know that e to the negative x is always positive, so this is always positive. So if I plug in 0 here, cosine of 0 is 1, and sine of 0 is 0. So we get positive and a positive. So this means that f prime of x is positive. And I'm just honestly going to assume that f prime of x is going to be less than 0 here because I don't want to plug in any values between here. And I think that checks out here. So from negative pi over 2 to pi over 4 is when the derivative is positive. So that means when f is increasing. So boom, it's got to be D. That's a fun one. You always got to love the trig. All right, for 2, let f be the function with derivative given here, where a is a positive constant. Which of the following statements is true? So f is decreasing, decreasing, decreasing. Okay, so let's go ahead and check this. Now, we're not using any specific values right here, but you can still apply the same thing. So when will this equal 0? That's going to equal 0 when x is equal to negative a and positive a. So let's... Okay. Yep. Okay. I'm not going to need... Should I use a graph? No. Not a number line. I'm going to use a graph instead. So we're going to use a graph instead of a number line, but a graph can be better. So we know that the derivative, f prime of x, is going to have a 0 at negative a and at some value positive of a. And because this is a quadratic, it's x squared, which means that the function, the derivative, so f prime of x, has to be a quadratic that looks like this right here, has to be upward facing, and that means the vertex has to be below, and these have to be the intercepts. So this tells me where the function is increasing or decreasing. So it's all asking for when f is decreasing. F decreases whenever the derivative, f prime of x, is negative. And you can see from this graph right here that f prime will be negative between negative a and a. So f is decreasing from negative a to a. This is the only one that says that because f prime of x is less than 0 from negative a to a. So it's got to be a. Wow. A, and the answer is A. Cool. All right, for 3, nice. I see a calculator. So let f be the function given here with the derivative of f prime of x. So we're given the derivative of f prime. That's what we're going to graph into Desmos. So we'll go into Desmos. All right, and let's go ahead and graph that. So we're going to graph sine of x. So sine of x plus cosine of x, cosine of 2x, and then minus pi over 4. Okay, here's our function. We're talking about between 0 and pi, so I'm going to add that in here. So between 0 and pi, not between 0 and poo. You want to know what's funny? Just because I just typed that in there, I had a companion. Oh, come on. I had a companion on my mission, and that was his he was from China. That was his last name. Like, that's literally how you spell his last name, like P and a U. And you literally said his name was Elder Pooh. Like, not even kidding. Like, that's a true story. I had a companion named Elder Pooh. Anyways, imagine that, 2 missionaries, Beverage and Pooh. Weird stuff. We got all the nicknames in the book, okay? All right, so let f be a function with the derivative given as f prime of x is equal to sine of x plus, okay? On which of the following intervals is f increasing? So basically what we're looking for when f is increasing, this means when f prime of x is greater than 0. So let's go in here. When are we greater than 0? It's when we're above the x-axis. So I see between 0, so between x equals 0 and x equals 0.724, and between 2.418 and to the end of the interval, so I guess to pi. And so which one does that match up with? think it's B. I think those were the numbers that I saw. All right, for f, let f be the function given here. On which of the following open intervals is f increasing? Oh boy. Man, I really just want to give you guys permission to use a calculator on this one. But let's power through this. So let's hold up. Is that the same thing? E to the negative 2x x squared plus, oh, that was those are like almost the same. No, okay, that was almost the same. Oh, if that's the same, then this is gonna take a while. Not really, maybe. Okay, let's just do it. So f prime of x. So f prime of x is going to be equal to, we have to use the product rule. So we'll do the first times the derivative of the second. The derivative of the second is going to be negative 2 e to the negative 2x. And then plus the derivative of the first, which will be 1 plus 2x, times by the second, e to the negative 2x. Now I'm going to factor out an e to the negative 2x from here. So I'm going to factor out e to the negative 2x. Now if I factor this out right here, this still needs to multiply inside there. So that's going to be negative 2x minus 2x squared. And then over on this side, we took out this e to the 2x, but we're left with 1 plus 2x. So plus 1 plus 2x. And then, so I get that the f prime of x is equal to e to the negative 2x. And then this will simplify because we have negative 2x squared. And then we have negative 2x, positive 2x. So those are going to cancel, and then we'll get plus 1. So this is very similar to that one, which I guess isn't really that surprising. We're going to set this equal to 0. We can say again that e to the negative 2x will always be positive. All right, and then this right here, we solve that. So we'll get 1 is equal to 2x squared divided by 2. So we get 1/2 is equal to x squared. So x is going to be equal to 1 over root 2, which I'm assuming now that I'm looking at these answers that they're going to rationalize the denominator, which is dumb, but it happens. I don't know why. Sometimes they choose to not rationalize the denominator. Sometimes they choose to rationalize the denominator, but whatever. All right, so, and that's also going to be positive or negative. So positive or negative right there. So we found where it's going to be, where the critical points are. So negative root 2 over 2 and positive root 2 over 2. And then, so since we found those right there, we can plug in something like 0. Well, we know that this is always positive and never 0. So if we plug in something like 0 here, it's going to be positive and positive. So this tells me that f prime of x is greater than 0 here. If I plug in something like negative 3, again, this is always positive. So negative 3, well, that's going to turn into positive times a negative, which is going to be a negative number. And then you're going to add 1, which is probably still going to be negative. So, and then this will be negative, that's all positive. So f prime of x will be less than 0. That's going to follow with the same thing over here. And so when is it increasing? So I think between negative pi over 2 and pi over 2 right there. And for 5, okay, so we have another calculator one. So we can just do sine of x plus x cosine of x. So we're going to do sine of x plus x cosine of x, okay? And then specifically on the interval from 0 to pi. So from 0 to pi. And this is the derivative. Keep in mind that this is the derivative, not the function. And we're trying to see when it is increasing. So when is it increasing? It's increasing when the derivative is positive. So that's all along here. So that's going to be from 0 to 2.029. So that's going to be for B. All right. So for 6, let f be the differential function with the domain from 0 to 10. It is known that f prime of x, the derivative of f of x, is negative on intervals from 0 to 2, from 4 to 6, and positive on intervals 2 to 4 and 6 to 10, which of the following statements is true. So basically, they just told you what the number line should consist of because we're talking about f prime. So we're talking about from 0 to 10. It is and then we have points like 2 and 4 and 6. So we're saying that 0 to 2 and 4 to 6, it's negative. So 0 to 2, 4 to 6 is negative. So that means that, okay, so I'm just going to put negatives. So negative, negative, positive, positive. This is for f prime of x, which means that f is decreasing here, then increasing, and then it's increasing, then decreasing, then decreasing, and increasing. So what is true right here? So f has no relative minimum, but it has 3 relative maximum. No, there are minimums here. F has 1 relative minimum. I think we have 2 minimums and 1 maximum. So we're going to have, let's see, f has 2 relative minimum, 1 relative maximum. So I think it's C, but f has 3 relative minimum. No, so yeah, it's got to be C. All right. Let f be the function given here. Which of the following statement is true? So we have the derivative, and it's kind of the same question. We're just going to use a calculator. So let's go ahead and check this derivative right here. So this is a derivative function, by the way, not the actual function. So we have x to the third minus 3x and minus 2. So we can see that the derivative is mostly negative. It's 0 at -1, but it doesn't change sign. So the derivative doesn't go over the x-axis, which means f is still decreasing. So I think we go from decreasing to increasing. F goes from decreasing to increasing at 2. So f should have a minimum at 2. So 1 minimum. It doesn't look like there's any maximum according to that right there. So f has no relative minima but 1 relative maximum. I don't think that that's true. F has 1 relative minimum and no relative maximum. I think that that's true right there. F has 1 relative minimum, 1 relative maximum, no, and then no. So yeah. So again, when you're looking at this graph right here, I'm looking at whether or not the function is below the graph or above the graph. That's what I'm looking for. It's below the graph for the entire function, except for when it changes from at x equals 2 and it goes from above and below. That tells me that f prime changes from negative to positive. That tells me that f changes from decreasing to increasing, which is where minimums occur. For 8, the function f is defined by f of x is equal to x squared. Okay, at what values of x does f have a relative maximum? So let's go ahead and use the first derivative test, I think. So f prime of x is going to be equal to the first times, why are these derivatives the worst? Not really. So f prime of x is going to be equal to x squared e to the negative x squared, but we have to multiply by negative 2x. So the first times the derivative of the second plus the derivative of the first times by the second. All right, I'm going to factor out an e to the negative x squared. So I think my pencil's dead. This is not good, guys. This is not good because my mic is currently plugged in to my iPad through a lightning cable. And that's how I charge my pencil. I charge my pencil by plugging it into the lightning port of my iPad. So if I unplug my mic, you won't be able to hear me talk. This is a problem. And I don't know what to do. Because my pencil is dead. Because I ignored the notification earlier today in 4th period. Okay, so you guys are I'm gonna voice this, all right? So the function f is defined by given here. So I have the derivative. What I'm gonna say for you guys to do is factor out an e to the negative x squared. Now, if you factor out an e to the negative x squared here, from both terms, and sorry, not e to the, I'm saying, did I write something down wrong too? So yes, I did. This right here should be e to the negative x squared, not e to the negative 2x. So, and I can't fix that. So you're going to factor that out. I'm sure there's a setting in here where I can draw with my finger, but I don't want to go change that setting. Can I just go to the help? Anyways, so you're going to factor out an e to the negative x squared. Here, that's going to make this negative 2x cubed when you multiply them together. So you have negative 2x cubed, and then you have plus 2x. So this is so hard to keep track of mentally right here. So you're just going to set them equal to 0. You're going to find the zeros, and then you're just going to use the first derivative test, see where it changes signs. Honestly, that's the best I can do right now. For 9, let f be the function given here. So we have 3 to the x squared minus x to the third. What is the absolute minimum? So this is referring to the candidates test. So 9 and 10 are referring to the candidates test. So you're going to use the endpoints. So we have the endpoints negative 2 and 2. So you can make a table with negative 2 and 2. For this one, you can make a table with the endpoints of 1 and 2.5. And then you're going to find the critical points by taking the derivative and setting it equal to 0 and finding the zeros. The good thing is that these are just polynomials, and polynomials are really easy to find zeros of. And then you're just basically trying to see where the minimum is, so which one is going to produce. Now to find the minimum, so once you have the critical points and the endpoints, you're going to plug critical points and endpoints into the function, not into the derivative, but into the function itself. And you're trying to look for which one will produce the smallest value in order to get that right there. And then you'll do the same thing for 10. So sorry that my pencil died and I can't explain the rest, but hopefully the key will have some explanations for you as well, or you can just use the Bev GPT tool. But I think that's it for me for tonight. So good luck.